Hi, so I'm going to continue with the transcendental functions. Range. This is really strange. Guys, this is not working. Now it is. So, it'll be the integral of dx divided by the square root of e to the 2x minus 1. Okay, so this is strange because the x function is behind the negative sign, okay, inside the square root, so I know that there's going to be an arcsecant. But there should be a u here, right, or some kind of u, and there isn't, apparently. So let's try to do this. U equals e, well, this is going to be u squared, e to the 2x. That means that u equals e to the x. Dx, okay, how can I explain this? Okay, du dx equals e to the x. So we put the dx over here and get it out of here, right? And then we get this ex over here and move it over. Okay. So this, oh yeah, and the a squared equals 1, so a equals 1. So this is going to be equal to the integral of du over e to the x, right, square root of u squared minus a squared. So you see, apparently it's in the wrong way. It's in the wrong format over here, but it's actually in the right format when you substitute, okay? Because now this is u, okay guys? This is u. So this is in the right format. So it's going to be 1 divided by a, right? Arc secant of u divided by a. And this u has to be in absolute value. Yeah, okay. So it's going to be 1 divided by a, which is just 1. Arc secant of the absolute value of u. What is u? E to the x divided by a, which is just 1. So there you go. There's something else too. If you want to do arc secant of e to the x, you can, because e to the x is always going to be positive, so it doesn't matter if you put in the absolute value operator or not. Okay, so another one is the integral of x plus 2 divided by square root of 4 minus x squared dx. Okay, so one thing that you can do is to separate these things. It's going to be x over square root of 4 minus x squared plus integral of 2 divided by the square root of 4 minus x squared. And all of these are going to be dx's, right? So, well, over here you have this x in here, so you don't have this arc sine or cosine or cotangent as secant because you have the x in here, right? So what is this? This is the same thing. Let's do this one here first, okay? So you have the integral of x, and then it's going to be, well, times 4 minus, I'm going to do the integral straight. 4 minus x squared to the minus half. Okay? So you gotta increase and divide by that stuff. Okay, so let's do that. So it'll be 4 minus x squared to the half, because minus half plus 1, half. Divided by half, so that means that's being multiplied by 2. Divided by the differential, you have this x in here. Divided by the derivative of the inner function, which is minus 2x. So you cancel this x with this one, and this 2 with this one, and you're just going to be left with minus 4 minus x squared to the half. Okay, so this is the first part. Okay, I'm going to erase this in here, and I'm just going to do this. And then you got a plus in here, and now you got to worry about this one. Okay, so this 2, you can just put it outside here. So it's going to be 2 times, and then what do you have? Dx divided by the square root of 4 minus x squared, right? Well, okay, so this is going to be an arc sine of u divided by a. Okay, well, in this case, u is just because it's x, so it's going to be x divided by a, and a is going to be 2. Okay, it's kind of obvious because you don't have a u now. Why am I not back substituting this? Because you don't have a u. Okay, this is going to be just in the format. This is in this format, guys. You got a dx in here, and then you have the square root of a squared minus x squared. You don't have a u. It's not u squared. So, yeah. You guys probably went deaf now because I messed with my closing here. And that makes a weird sound in the microphone. So, that's it, guys. This is it. You can put a plus c there, right? As always. Let's try another one. Let's see. The integral of dx divided by x squared minus 4x plus 7. Okay, let's do that. Well, in here, you're just going to have to complete the square. You realize that all of this is being elevated to the power of 1, so you could do ln of x squared, right, minus 4x plus 7, but then you have to divide by the derivative of the inner function, which is going to be divided by 2x minus 4. You would have to have a 2x minus 4 in here. If you had, this would be over, okay, but you don't, so you can't do that. So this is going to be equal to the integral of dx, and then you see what I'm going to do is to say I'm going to complete the square. So I have x squared minus 4 plus 7. This is the b term. Okay, so all you got to do is to say, well, just care about the magnitude, not the sign. So 4 divided by 2 is 2, and you get this 2 and you square it. So it's going to be plus 4 minus 4. Now you get this, 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 and this. Okay, now you have to worry about the sign. And these 3 terms are going to be x minus 2 squared. So you have x minus 2 squared. And what are you left with? Plus 7 minus 4, so plus 3. Okay. Now in here you have a u, because this is u, okay? So let's do that. U squared is going to be this thing squared, so u equals x minus 2. Du equals 1 dx, right? So du equals dx. And a squared equals 3. That means that a equals the square root of 3. And you have a plus here in the denominator, and you don't have how can I explain this? You don't have a square root, so this is going to be an arctangent, right? So let's put this in the right format. You have a du, because the u is this, so du is just going to be du dx, it's just going to be 1, so yeah. So I have a du there, okay, divided by u squared, the integral, right, u squared plus a squared. So this is going to be 1 divided by a arc tangent of u divided by a. This equals 1 divided by the square root of 3 times the arc tangent of u, which is x minus 2, divided by the square root of 3. Yeah. I'm thinking here. The integral of dx over the square root 3x minus x squared. Well, let's do this. So let me think. What you can do is say that I have 3x minus or you can say that you have a minus, and then you got a minus 3, because you want the leading coefficient here to be 1. When you are completing the square, this has to be 1, not negative 1. So minus x plus x squared, okay? This is it. And now you can complete the square in here. So it's going to be minus, and we do, well, let me do this the whole way. So it's going to be 3 divided by 2, and the square, that is 9 divided by 4. So you have plus 9 divided by 4 minus 9 divided by 4. I'm going to put this even further. Minus 3x plus x squared. And this is going to be equal to minus. And you get the minus divided by 4. Minus 9 divided by 4. And you have a plus. And then you have x minus 3 divided by 2 squared. Okay, this is what you have, and then you can plug in the thing again. So this is going to be equal to 9 divided by 4 minus x minus 3 divided by 2 squared. So you have the integral of dx, and then you have this, and then you have a huge square root of this thing here. Oh, hold on. I'm going to put it very close like this. Kind of like that. Yeah, that's good enough. Okay, here's the square root of all this thing. Now what you can do, this is gonna be 3 divided by 2 squared, okay? So I'm also gonna do this. This is 3 divided by 2 squared. Okay, so here we go again. This is the square root, okay. U equals x minus 3 divided by 2, okay? Du equals dx a equals 3 divided by 2, right? So this equals the integral of du divided by the square root of a squared minus u squared. So this is just going to be the arc sine. So we do this arc sine of u divided by a, x minus 3 divided by 2, and this whole thing divided by a, which is 3 divided by 2. Okay. Now, of course, you can put this thing in the proper order. Okay, but you don't have to. You could, but I'm just going to leave it like that. Doesn't matter. And I don't know if I'm done. I think I'm done. Let's see. Okay, before we finish, let's just do something here. A few more exercises. You see, you're going to have dx, and I'm going to make these 3 exercises. I'm going to try to do this. Okay. Dx of x square root of x squared minus 1. In here, you're going to have the integral of x dx divided by the square root of x squared minus 1. And over here, you're going to have the integral of dx divided by square root of x squared minus 1. So you see that the denominator kind of looks the same, okay? So let's see all these things in here. In here, you can see that you have a u, okay, which is x squared minus 1. Du equals 2x dx. So you're going to get this thing in here and put it there. Okay. I'm going to get this dx closer. There. Okay. And let me think here. Well, oh, u is not going to be x squared minus 1, guys. I'm sorry. I'm sorry about that. U is just going to be, yeah, u is just going to be x squared. Okay, so you don't have to use substitution in this case here, because you can see that this is already in the format x squared minus 1, which is a squared. Okay, but since it's 1, you don't have to worry about that. This is just going to be the arc thing, the arc secant. Okay, because you have the, what do you have in here? You have x squared. And here you have an x, okay? So whatever this is, you have to take the square root of it and put it here, and that's what you have. So this is just going to be the arc secant of x, okay? Plus c. All right. Over here, you do have, you see, the derivative of the inner function, which is 2x, you got an x here. It's something that in this part you don't have. That's why you have to use the arc secant. So this is just going to be, well, x squared minus 1 to the minus half plus 1. So x squared minus 1 to the half divided by half. So it's being multiplied by 2 divided by 2x. And you have this right? Because it's the it's the derivative of the inner function, and you also have this x in here, so you copy it over here. You cancel this with this, and you cancel this with this, and this is the answer, okay? X squared minus 1 to the 1/2. Okay, this one, you don't have anything. You don't have an x in here. You don't have some kind of x in here. So far, you haven't learned any techniques to solve this. You're probably going to be able to solve this thing here with integration by parts, but we haven't seen that yet. So, yeah. I'm going to repeat some exercises here. Dx over x ln of x. Okay? This is going to be equal to, well, you see, worry about this function right here, ln of x. What is the derivative of that? 1 divided by dx, and you do have 1 divided by dx in here. 1 divided by x, and you do have 1 divided by x here. So this is going to be the ln of this function. So ln of x, okay, divided by the derivative of this function, which is 1 divided by x. But you do have a 1 divided by x in here too already, multiplying this. So, let me see. So you do have a 1 divided by x in here multiplying, okay? So you cancel this one with this one, and that's it. ln of x. Let me see here. Let's do something different. You have the integral of ln of x divided by x dx. Again, think about this thing here, okay? Can you do that? Yes, you can. It's going to be ln squared of x divided by 2, okay? And you have to divide it by, because you see, ln to the power of 1, this 1 in here is going to be the outer function. I know that it's not even there, right? But that's the outer function. So it's ln squared of x divided by 2, because if you're taking this thing, you have to divide it by 2. All right? Divided by the derivative of the inner function. And what is the derivative of the inner function? It's, well, what's the inner function? ln of x. So the derivative of that is 1 divided by x. So when you divide, you got this x in here, right? Got this x in here. Okay, I'm just copying. And now you have to divide the whole thing by 1 divided by x. So actually what you're doing is multiplying 1 divided by x in here. Well, this thing is already in the denominator. So this x in the denominator of the denominator is the numerator. It comes up, all right? So when you divide by 1 divided by x, you're actually multiplying by x. And now you cut this one, you simplify this one, and that's the answer. ln squared of x divided by 2 plus c. Now, here's the thing. The integral of ln of x dx. No, you can't do anything with this yet, okay? That'll be it for this video, guys. I'll see you guys on the next one.